Yeah, everybody, look at this. We were solving this particular problem in the last class. Okay, we have solved this particular problem. Okay, but let me just see it again because I had not given you the whole result. Okay, I actually had asked you to go through this yourselves. Okay, so let me do this particular second problem that we had taken earlier. So if you apply Laplace transform, what would happen? So f1 of t we obtain. After obtaining f1 of t, we need to apply Laplace transform on this. Okay, so f of t is given like this. We were dealing with the periodic functions. Okay, so we were asked to find the Laplace transform of f of t, which is periodic in nature. And when it is periodic in nature, you should just consider the pattern which is repeating itself. So which is the pattern which is repeating itself, and what is the duration of that pattern? The duration of that pattern is 2 seconds. Okay, so 2 seconds, after every 2 seconds that particular pattern is repeating itself. So in that sense, this is periodic signal. Okay, and since this is repeating after every 2 seconds, that 2 seconds is called as the fundamental period. Okay, so that is the C, where t is the fundamental period, that is 2 seconds. Fine. So how did we find out the Laplace transform of this? To find out the Laplace transform of this, we need not have to consider the whole periodic signal. We just have to consider the pattern which is repeating, and let us call that as f1 of t, as we had decided earlier. Fine. And how to express this in terms of mathematics? Fine. So it's a combination of a ramp, okay, which is of slope 1. Why slope 1 ramp we need to consider? Because see, it is 2, this ramp is having an amplitude 2 at t equal to 2. Understand that? Similarly, if it is 2 at t equal to 2, it would be 1 at t equal to 1, 3 at t equal to 1, 4 at t equal to 1. So the slope is 1. So that's why we have considered the ramp of slope 1. Okay, and this ramp is not extending from 0 to infinity, it is extending just from 0 to 2. So how to limit this particular ramp from 0 to 2? By multiplying this ramp by a signal whose amplitude is 1 from 0 to 2. That is this signal. Okay, and what is the equation of this ramp? The equation of this ramp is t. Why the equation of this ramp is t? Because at 1, at t equal to 1, the signal is 1. At t equal to 2, the signal is 2. At t equal to 3, the signal is 3, means the signal is actually t. Okay, and we have seen how to express this in terms of unit step functions. Okay, it starts at 0 and it ends at 2. Okay, so how to construct such a rectangular waveform through unit step? It is like this. Consider a u of t which starts from 0. Consider another u of t which starts at 2. Okay, and subtract the u of t which is starting at 2 from the one which is starting at 0. You will get this. Okay, this exercise we have done earlier. Fine. So what is f1 of t? If you multiply these two, you'll get your f1 of t. Understand that? Okay. So that is why f1 of t is written as t into this signal multiplied by this signal. Okay. And this is what we have arrived at. Okay. And when we got this, what was the, this is fine. What is the problem here? Here, one is function of t, another is function of t minus 2. Okay, so that will not do. Both the functions have to be functions of t or functions of t minus 2, as the case here. See, this is also function of t, this is also function of t, so absolutely no problem. But here in the second signal, this is function of t, but this is function of t minus 2. So I cannot make this t, so rather try making this t minus 2. How? By adding and subtracting 2 from t. And once you write this, how would you split this into two signals? Is like this: t minus 2 into u of t minus 2 plus 2 into, sorry, this is minus, right? Minus 2 into u of t. So if you don't understand how to write this, just see how you can convince yourself. So you have these two terms, right? How to get this term out of this, which is common term here? U of t minus 2 is common. Keep u of t minus 2 out. Okay, minus rather, minus u of t minus 2 out you keep. Okay, then see you will get this. Fine. So if you apply Laplace transform on this, how is it going to look like? Okay, so it's t into u of t. I've been telling you, since u of t is with another function of t, I don't consider this when I'm applying Laplace transform. It is just telling that t ranges from 0 to infinity, and this is just telling that t minus 2 ranges from 2 to infinity. Okay, but here this is a unit step function which is starting at 2, because it is not there with another function of t. So in that sense, we can have our fn of s equal to what? 1 by s square minus, since there is a shift, it is e power minus 2s divided by s square, because there is t minus 2 is the function, minus 2 into e power minus 2s, because again there is a shift, but the signal here is u of t, that's why it is 1 by s. Understand that? So what would you write your f of s as? So therefore f of s would be what? 1 by 1 minus e power minus 2s into this 1 by s square minus e power minus 2s by s square minus 2 e power minus 2s by s. This is how the things go. Understand that? So this is what I wanted you to obtain in the last class. I hope you have got this yourselves. Those who have not got, see, you need to be working hard. Fine. So let's take another problem. Fine. Everybody copy this. Find the Laplace transform of, this is problem number 3. Okay, 2 problems we have seen. Okay, so now we shall see problem number 3 as far as the periodic signals are concerned. Fine. So problem number 3, what is it saying? Find, everybody copy this, find the Laplace transform of f of t. Okay, so when they have asked us to find the Laplace transform of f of t needs to be given, isn't it? So what is that f of t? F of t is a periodic signal. Okay, how does it look like? It looks like this. Everybody just copy this down. These dotted lines indicate the x-axis and y-axis, and the solid lines indicate the signal. Okay, this is one pattern. So similar patterns should repeat. Okay, like this. Fine. So this will repeat. Okay, because all periodic signals will keep repeating uh, and would extend till infinity. Okay, so this is the f of t given. Fine, and its amplitude is 2. Okay, 0, 1, 2, 3, 4, and it just goes on and on and on. So this is what is the signal. Okay, so have you seen this signal earlier? We were talking about sawtooth waveform, right? Is this the sawtooth waveform we had seen? Let's go to problem number 1. I think we had taken sawtooth waveform there. Did we? Yeah, see this? The previous problem itself. See, how did we do previous problem? See, this is the sawtooth waveform. Okay, how this waveform is different from this waveform, you need to see. Okay, so this is the combination of, again, two functions. This also is a combination of two functions, but see the ramp here. Ramp is going like this. See the ramp, that is why I call it as ramp, going like this. But here what's happening, there is a line going like this, and I don't want to call that as the ramp. Okay, if it is like this, it is ramp, but the line is going like this. So let's not call that anything. Let's just call it as maybe the function fe of t or f1 of t, something like that. Okay, so first let's consider the construction, okay, or expression of this. So let's first consider the repeating pattern. Which is the repeating pattern? Everybody just see this. Just consider the repeating pattern. Which pattern is repeating? So see here. Okay, 0, 1, sorry. 0, 1, okay, and this is 2. Fine. Now see here, the the periodic function or the periodic signal is f of t. Since we are considering just one pattern which is part of that periodic signal, let's call it as f1 of t. Understand that, everybody? Now how to construct this f1 of t is the question. Now everybody see here. Now what I want is two signals. Okay, which are those two signals we're talking about? This is time axis, the x-axis is time axis. Fine, I want this. So that means what I can do is I can rather consider a signal. Let me do this. Everybody, I hope you can do it easily on. Let me take a line properly. Okay. Yeah. Everybody just it's not responding. It's yeah. I'll take a line from here. Fine, and that line will just keep extending like this. So this is one signal I want. This is one signal. What do you call this signal? What do you call this signal? See here, this is not a ramp. If it is ramp, I would have written it as t. At at 0 it is 2. Okay, at 1 it is 0. So I cannot consider it as a ramp. What happened with the ramp here? See here, everybody. What happened with the ramp? See, at 1 it is 1, at 2 it is 2, so the given ramp is t. Is this line t? No, it's not t. For this to be t, at 0 this should be 0, at 1 it should be 1. That's not happening. So that means it's a line. We understand it's a line. So how to obtain the equation for line I have shown you. Okay, so consider 2 points here. Consider 2 points. One point is what? One point, let's say x coordinate is 0, y coordinate is 2. Okay, here x coordinate is 1, y coordinate is 0. Understand that? So what is the equation for this line? So what is that? See here, y minus y1 divided by x minus x1 equal to y1 minus y2 divided by x1 minus x2. This is how we can construct the equation for, or we can get the equation for line. Okay, see here, what is y here? What is y? So let us call this as, this we have called as f1 of t, right? Let us call this as fa of t. Okay, so y is fa of t minus y1. Y1 is what? 2. See, this is x1 y1 x2 y2 divided, what is x? X is the time axis, time. Okay, minus 0 equal to, so 2 minus y2 is 0, 0 minus x2 is 1. So this is how things go. Okay, so therefore this implies that our fa of t is actually what 2 minus 2t it would become. Okay, so what is this line now? This line is 2 minus 2t. Okay, and I want this line which is 2 minus 2t just to be extending from 0 to 1. So what you would do with this then? Just extend this line, extend this line. Okay, let me call this as fb of t rather. Okay, then I need a signal which would just select this part of that particular line. So that means I need a signal which extends from 0 to 1 and whose amplitude is 1. Okay, so this is fa of t, this is fb of t. What is fb of t now? This fb of t is what? U of t minus u of t minus 1. Okay, so how to obtain f1 of t now? F1 of t can be obtained by multiplying these two signals, fa of t and fb of t. Okay, so therefore we can say our f1 of t is actually multiplication or the product of fa of t and fb of t. What is fa of t? Fa of t is, see here, it's 2 minus tt, which we have obtained by doing this exercise. Okay, so that's 2 minus 2t, fine, being multiplied by fb of t. That is the second thing. What is that? It's u of t minus u of t minus 1. So this product is what f1 of t is. Fine. So bring this to the proper form so that we can apply the Laplace transform on this. So what is that proper form we are talking about? Let's first get this 2 into u of t minus 2 into u of t minus 1. Okay. Then minus 2t into u of t. Okay. Minus of minus plus 2t into u of t minus 1. So this is how the signal looks like. Okay, the first three terms are fine. So this term is u of t, it's fine. This is shifted version of u of t, it is fine. This is t. The signal is t here. So this is also fine. But here one is function of t, other is function of t minus 1. So this needs to be modified to get the answer. Okay, so let's do that now. Okay, so this implies that our f1 of t can be written as 2u of t minus 2u of t minus 1 minus 2tu of t. So these three terms have no problems, but here you need to be a little careful regarding this. So I want this to be t minus 1, right? So to do that, you add and subtract 1 to that. Okay, fine. So all the terms would remain like that. Okay, so this further implies what? Our f1 of t would be 2u of t minus 2u of t minus 1 minus 2tu of t. Okay, plus now how to do this? Anybody would like to uh, say how can we split this particular signal into two signals? Anybody would like to try that? Give it a try. So we have to split this into two signals. So how can we do that? So it's 2 into t minus 1 into u of t minus 1. Okay, plus 2 into u of t minus 1. So if you are not happy with what you have done, just go to the previous step from this particular step. What is that? What is the common term here? 2 into u of t minus 1 is the common term. Okay, if you take that out, you would be left with t minus 1 plus 1 in the bracket. So that is how you can verify whether what you've done is right or wrong. Fine. Now this is in the form that we need. Now say just apply Laplace transform. So f1 of t would become capital F1 of s. Okay. So it's 2 by s minus u of t shifted. So the shift is minus 1. So it's e power minus s divided by, so it's 2 is there, not supposed to miss, by s minus t is there. Now u of t is not the signal, t is the signal. So it's 2 by s square because there is no shift, so no exponential in that. So minus 2 into there is a shift, so exponentials need to be there, and yet that exponential is e power minus s divided by s square because the signal is t. Fine. Plus 2, shift is there, so that shift results in e power minus s, and since u of t is the signal, basic signal, it is 1 by s. So this is your f of s. Understand that? This is your f of s. Fine. Now everybody get me f of s. If 1 of s is obtained, can you get me f of s? So what is f of s? Therefore f of s is what? f1 of s divided by 1 minus e power minus ts, where t is the fundamental period. What is fundamental period? After how many seconds it's repeating itself? See here, after every 1 second the pattern is repeating, right? So we can say the t, which is called as fundamental period, as 1 second. Fine, where t is 1 second. Okay, so you just have to substitute this f1 of s here and say that your f of s is this. That's all. So it's a 1 by 1 minus e power minus s, because t is 1. Okay, into this what we obtained in the previous step. Uh, yeah, you can take common term out and you can do that. Okay, I'll just keep it as it is. Okay, should not be a problem. You can just keep it as it is. And this is your f of s. Fine. So we shall take one more problem, and that would be the end of this particular Laplace transform chapter. Okay. Now let's move on with that last problem. Maybe we'll just copy this term fast. This is our fourth problem. Not a periodic signal, but it's a staircase signal, we call it as. Okay. Copy down this. Find the Laplace transform of the staircase waveform. You will understand why it is called a staircase waveform when I show that. Staircase waveform shown. You have to obtain the Laplace transform of the staircase waveform shown. So how does that look like now? Everybody just copy this down, make it fast. Yeah. See how it goes? It goes like stairs. Okay, that's why it is called as staircase waveform. So it's 1, amplitude 1, amplitude 2, amplitude 3, and there's one more step at 4. Okay, and after that, this steps, the last step after this fourth step, the signal would come down. Okay, so this is how the signal is. Okay, at 0 it starts, and it is 0 from 0 to 1. It is 1 from 1 to 2. It is 2 from 2 to 3. 3 from 3 to 4. Okay. And 4 from 4 to 5. At 5, it comes down. Fine. This is how the signal is, and they have called the signal as V of t. Now the question is this periodic in nature? Because we have been seeing periodic signals, okay, wherein you had a pattern which is repeating itself after a particular duration. Is that happening here? Is that happening in this staircase waveform? No. Okay, see, there is no pattern. If you take this pattern, the same pattern is not repeating. Okay, so it's an amplified pattern which is coming here. Again, it is amplified pattern, amplified. So all these are the amplified version of the previous version. Okay, so there is no identical pattern which is repeating itself after every duration, every say t duration. Okay, so it's not a what staircase waveform is not a periodic signal. So not a periodic signal. But we need to construct this. So which waveform do you think would help in constructing this particular staircase waveform? We need to look at. Fine. Now just put this in terms of numbers. Okay. So everybody just see this in the solution. Let's say mathematically, what is V of t? V of t is actually 1, isn't it? For t greater than 0, sorry, t greater than 1, it's not 0. For t greater than 1 and less than 2. Fine. Then I have the second step, that is 2 for t greater than 2 less than 3. Fine. Then you have 3 for t. Let us put this semicolons here. For t greater than 3 less than 4, and it is 4 for t greater than 4 and less than 5. Everywhere else, what is it that also needs to be written? 0 otherwise. 0 otherwise means uh, except these ranges, okay, the signal is 0. So you need to put this. Get that? Now this is what it is, but we have to be a little smarter to express this in terms of the basic signals. These are all just numbers, right? These are all just numbers, but I need to somehow associate these numbers with any of the basic signals you have seen so far. So which basic signal do you think would define the range? Which is range defining basic signal that you have seen? It's a unit step function. Okay. And we know unit step function is 1 from 0 to infinity. But do you know a unit step function which goes from 1 to 2, 2 to 3? Okay. So that exercise we have done. Fine. That's why our V of t can be written as V of t in terms of unit step function. Unit step or shifted unit step. Okay. Is. So how does it look like? See here, this is V of t. It is 1 from where to where? It is 1 from 1 to 2. So which is your u of t, which is 1 from 1 to 2? It is u of t minus 1 minus u of t minus 2. Everybody understand this? So this is V of t is 1 from 1 to 2. So how to say it is 1 from 1 to 2? By considering a signal rectangular wave which ranges from 0 to 2 with amplitude 1. That is this. Similarly, the second part of it is 2 and it is ranging from 2 to 3. That means which is the signal whose amplitude is 1 ranging from 2 to 3. That is this u of t minus 2 minus u of t minus 3. This we have done earlier. I'm just making use of that uh, results that we have obtained in the previous classes. Okay. Then we have 3 and this 3 extends from 3 to 4. That's why it is u of t minus 3 minus u of t minus 4. Plus there is another term which is 4. Okay, and the range is from u of t minus 4 to u of t minus 5. This is what is the range 4 to 5. So this is the signal. Fine. Now you just multiply these and let's see if we can simplify this particular equation into lesser number of terms. Fine. So just see that v of t is u of t minus 1 minus u of t minus 2 plus 2 times u of t minus 2 minus 2 times u of t minus 3 plus 3 times u of t minus 3 minus 3 times u of t minus 4 plus 4 times u of t minus 4 minus 4 times u of t minus 5. Okay, and if you see this, this would result here. You have t minus 1 here, so that would be as it is. You have 2 u of t minus 2 and minus u of t minus 2. So you'll be having just 1 u of t minus 2 from these two. Similarly, you have 3 u of t minus 3 minus 2 u of 3 minus. So this is so beautifully arranged that your v of t would finally be in the simplified form, which looks like this: u of t minus 1, okay, plus operating with these two. See here, operating with these two, what you would get: u of t minus 2, okay, then operating with these two, what you would get? Again, you would get u of t minus 3. Similarly, with these two terms, you would have u of t minus 4, and the last term would remain as minus 4 u of t minus 5. Very simple stuff, provided you are good with the expression of signals in terms of the basic signal. Fine. Now you can easily go with the application of the Laplace transform. Therefore, applying Laplace transform implies v of s equal to, there is a shift, so its shift is e power minus s, because its shift is 1 by s, plus e power minus 2s by s, plus e power minus 3s by s, plus e power minus 4s by, yes, because 1 by s, because it's all unit step functions. Okay, there is no ramp, there is no t along with it. If there is a t along with it, you have to be, yeah, anybody?
Yeah, ఇక్కడ నేను దాని వాడికి మధ్య
Yeah. So finally, what you have? Finally, you have what? Finally, you have minus 4, right? So it's 4 e power minus 5s by yes. So this is how the things look like.